Hello, physics students. I am Mr. Williams, and this week we're going to start talking about electromagnetism. Okay, let's make it real simple. Let's think about the word electromagnetism. Well, what's the beginning of the word? Electro. Well, we're thinking about electricity if we're thinking about electro or electrons, and electrons, when they flow down something, that's electricity, so electro. And then we have magnetism. Well, what's magnetism? Well, that's just the study and the interactions of magnets and magnetic fields. So this word combines using electricity to make magnetism. All right. So that's what it's about. And it's really cool because it does all the neat stuff that we know and love. And so let's find out what that stuff is. So let's talk about an electric current. So an electric current is the movement of electric charges in a single direction. So a current is electrons moving from one place to another. And on the image over here, there is a direction of where the electrons are flowing and what direction the magnetic field lines are. And we'll talk about that in a second. When electric current flows through a wire, a magnetic field forms around that wire. Okay, so there is a magnetic component of electrons flowing down a wire. And if we know the direction of those magnetic fields, then we could use that magnetic field to manipulate other magnetic fields. We learned that opposite poles of a magnet will attract and like poles of a magnet will repel. Well, since we have electricity, we can use electricity to produce magnetic fields and manipulate magnets. And so that's how we build electric motors, for example. And so we design the way we shape and coil wires to create magnetic fields, and we just control the direction of the electricity. And then we have this interaction of magnetic fields, and we can get it to do work. The direction of the magnetic field depends on the direction of the current in the wire. Okay, this is called the right-hand rule. There's a couple of right-hand rules, and so if you Google this, you might want to look at the specific details of which right-hand rule you're talking about, because they can mean different things if you're talking about different phenomena. So if you take your right hand, right, and stick your thumb out, the thumb points in the direction of the current flow. That's the direction that the electrons are flowing. And then your fingers, which are cupping around the wire, that would show you the direction of the magnetic fields. Remember, previously we studied magnetic field lines and we said they had a direction. We said magnetic fields go from north to south. And so now we can see that if we have our right hand and our right thumb is pointing to the direction of the current flow, then the magnetic field would start, let's for example, our wrist and come up and around the wire towards our fingers. Moving charges and magnetic fields. A wire carrying electric current produces magnetic field lines that form circles. The direction of the magnetic field around the wire reverses when the direction of the current reverses. So if you need the magnetic field to go in a different direction, you make the electricity go in a different direction. As the electric current in the wire increases, the magnetic field increases. That makes sense if you think about it. If electricity, the flow of electricity, electric current going down a wire, or electrons flowing down a wire in a certain direction, okay, if you have a lot more electrons, then you're going to have a lot more magnetic field. The strength of the magnetic field decreases as the distance from the wire increases. So as you get away from the wire, you're not going to have the power of the magnetic field to be able to move and manipulate other magnetic fields. It's strongest closer to the wire. So let's talk about electromagnets. An electromagnet is a temporary magnet made by wrapping a wire coil with an electric current around an iron core. We're going to see different versions of electromagnets, okay? One we see right here, we don't have an iron core. This one would just be one loop. When a current flows through a loop, that magnetic field is stronger than it would be if it were going through a straight wire. It's something you're going to need to keep in mind. If you have a straight wire, you do have a magnetic field, but it's the weakest. If you have one loop, as you see in this image, it will be stronger than it was if it were just a straight wire. And we can see the direction of the magnetic field lines and the arrows of what direction that it's going. So next, how can we make the single loop of wire be a stronger magnetic field? Okay, well, we can make something that is called a solenoid. A solenoid is a single wire wrapped in a cylindrical wire core. So you just make lots of loops, basically. And so if you're familiar with cars, sometimes what goes out is a car starter. It's what gets the engine cranking and moving so the car starts. Well, it has a component in it called a solenoid, and sometimes they just get too hot and they burn out, and the wires, the insulation on the wires melt and it no longer works. Okay, so that solenoids are something that you should be kind of familiar with. But a magnetic field inside a solenoid is stronger than a magnetic field of a single loop. Okay, so it looks like we're getting stronger and stronger. A single wire is the weakest magnetic field, just straight wire. Then if we have a wire with one loop, it's a little bit stronger than a straight wire. How can we make it stronger? Well, we turn it into a solenoid. Remember, a solenoid would be that wire with many loops. Now, there's one more trick that we can do to make it even stronger. So if we have these many loops, right, we could stick in an iron core, right? We just put a piece of iron, an iron rod, and it makes the magnetic field more than 1,000 times stronger. The same number of loops, because the more loops you have, the stronger it gets. But even if you use the same number of loops and you just put a iron piece of metal in between it, let's say like in some middle school experiments, they would take a wire and wrap it around a nail, and they'd make the nail turn into a magnet and pick up paper clips. Well, just the fact you're wrapping it around the nail makes it many times stronger. A straight wire is the weakest magnetic field. Making one loop would make it a little bit stronger. Making many loops makes it even stronger. And then you take all those loops and you put a piece of iron inside of those loops, then it becomes much, much, much stronger. The magnetic field of electromagnets are temporary. Magnetic fields exist only when current is flowing. Two ways to increase the strength of the magnetic field. You can, one, add more turns of the wire. That means making more loops. Two, you can increase the current passing through the wire. And so you add more electricity. Electromagnets, okay, sometimes you'll see it abbreviated as EM, behave like permanent magnets if there is current. So they got a north pole and they have a south pole. So the solenoid has a north pole and a south pole. The single loop has a north pole and a south pole. The straight wire has a north pole and a south pole. Now, if you take these electromagnets and you place them in a magnetic field, electromagnets align to the magnetic field lines. Electromagnets will attract magnetic materials, so thinking like iron, cobalt, nickel, and stuff like that. And electromagnets can be attracted to or repelled by other magnets. So, like I said earlier, you have an electromagnet, if it's got north and south poles, magnetic fields, it can interact with other magnets. And so then you can have a push and a pull. And then if you just use electricity to create those electromagnets, then you can create motion. And motion can do things like turn a ceiling fan, make the motor in your cell phone spin around so it vibrates. Endless possibilities of things you can do with electromagnets. When current flows in an electromagnet and moves towards or away from another magnet, electric, excuse me, electric energy is converted into mechanical energy. So we have that electricity, we created a magnetic field. So since it is interacting with another magnet, that electric energy is being converted into motion and potential energy. And so right below that first bullet point, I say, remember, mechanical energy is kinetic energy plus potential energy. Electromagnets do work in devices such as speakers and electric motors. We'll talk about speakers next week. Okay, guys, that is all that we are going to cover for now. Stay tuned. Make sure to get your work caught up, do the best you can, and let me know of any issues that you're having because we want to get those resolved because we want you to be successful. Have a great day, guys.